When it comes to databases, it's never a question of if things will go wrong. It's always a question of when. And when that moment finally hits, a rock-solid backup strategy is the only thing standing between a minor headache and a full-blown catastrophe. So today, we're going to build that strategy for Postgres.
All right, here's our game plan. First, we're going to get to know the enemy, the ever-present threat of data loss. Then, we'll introduce our hero, the backup itself. We'll dive into its two main flavors, figure out how to combine them into a resilient strategy, and then, finally, put all those pieces together so you can build your own custom defense plan.
So first things first, let's talk about the bad guy in our story. The thing that gives developers and DBAs nightmares. The very real possibility of losing it all. Just think about it for a second. A single, mistaken, drop table command on your most important table. A critical hardware failure that just wipes an entire server. It could be simple human error, or it could be a malicious attack. But the result is always the same. A nightmare scenario where years of work and priceless data just, poof, gone. And look, this isn't some abstract hypothetical problem. For any real application, losing your data can be a literally company-ending event. It's this constant, ever-present threat. And just crossing your fingers and hoping for the best? That's not a strategy. Okay, but it's not all doom and gloom. We don't have to just sit there and be defenseless. We can build a shield. And that shield is built on a very simple but incredibly powerful concept, the backup.
So, what is a backup, really? At its core, it's simple. It's a copy. It's a second version of your data, tucked away in a safe place, just waiting to be called upon to restore everything when disaster strikes. It's your shield.
But a backup is so much more than just a copy. It's a time machine. It's what gives you this incredible power to just rewind the clock and go right back to the moment just before everything went wrong.
So now that we know why we need a backup, let's get into the how. And in the PostgreSQL world, you've basically got two main flavors to choose from, each with its own unique set of pros and cons. So first up, we have what's called a logical backup. Now, the best way to think about this is not as a direct copy of the files, but more like a recipe or a blueprint. It's a big text file full of SQL commands, create table, insert, that can perfectly recreate the state of your database from absolutely nothing. Now, the huge win with this approach, it's all about flexibility. Because it's just a set of instructions, you can restore it on a different machine, or a newer version of Postgres, maybe even a different database system altogether. It's perfect for things like migrations or upgrades. You can even pick and choose to restore just a single table. But, and this is a big but, the drawback is speed. Replaying every single one of those commands can take a very long time for a big database.
All right, on to flavor number 2, the physical backup. This one is way more direct. Forget the recipe. This is like an exact bit-for-bit clone of the actual data files on the disk that PostgreSQL uses to store everything.
And the biggest pro here? Pure, unadulterated speed. Restoring is often as simple as just copying files back where they belong, which is absolutely critical when your main goal is minimizing downtime. But of course, that speed comes with a trade-off. And that trade-off is flexibility. A physical backup usually has to be restored to a system with the exact same architecture and the same major version of PostgreSQL.
So that's really the core trade-off you're looking at, right? Do you want the slow but super flexible recipe, or the lightning-fast but much more rigid clone? And hey, there's no single right answer here. In fact, the most bulletproof strategies often use a mix of both.
Okay, so we've got our backup types, but let's kick it up a notch, because just having a single backup file sitting somewhere is good, but it's not nearly enough. To be truly resilient, you need a strategy. You need a system that weaves these tools together into a really powerful defense. And any good strategy has to start with a clear goal. The most important one is your recovery point objective, or RPO. And all this really asks is a simple question. How much data are you okay with losing? For most critical systems, the answer is pretty clear. 0, zilch, nada, not one single transaction. And to hit that near zero data loss goal, the absolute gold standard in PostgreSQL is something called point-in-time recovery. We just call it PIDR. So here's how it works. Step 1, you start with a solid foundation, a full physical backup of your database. Think of it as a complete snapshot, say taken at 2 a.m. on a Sunday. Then, and this is the key part, from that moment on, you start to continuously archive every single transaction log. You can think of these logs as a super detailed diary of every single change made to the database.
Every insert, every update, every delete. By combining that base snapshot with this detailed diary, you unlock the magic of Step 3, the ability to restore your database to any specific moment in time.
And that right there is the magic of PIT, IR. So if some poor soul accidentally drops a critical table at, say, 3:15 and 22 seconds in the afternoon, you don't have to roll back to last night's backup and lose a whole day's worth of precious data. Nope. You can restore to 3:15 and 21 seconds p.m., the exact moment right before the disaster happened.
All right, we've got the tools, we've got the strategies. Now it's time to do the most critical part, actually putting it all together into a real, documented, and, most importantly, tested backup plan.
A really solid plan is all about answering a few key questions. We've already talked about RPO, how much data can we lose? But now we need its partner, RTO, or Recovery Time Objective. And that asks, how fast do we need to be back up and running? That's going to determine your backup frequency and where you store them. Oh, and by the way, that location should never be the same server as your database. But honestly, the most important part of the whole plan?
You have got to test your backups, and I mean really test them regularly. Because listen, an untested backup isn't a plan, it's just a prayer. You've got to run drills, actually restore that data to a different server, prove to yourself and to everyone else that you can get back online when it really counts. If you don't, you might discover your shield is made of cardboard when you need it most.
So I want to leave you with this one question. Take a hard look at your own systems, your own projects right now. Do you just have a file sitting somewhere that you call a backup, or do you have a truly resilient, tested strategy? Because with the right plan in place, you can finally sleep well at night, knowing that no matter what happens, your data, your application's lifeblood, is actually safe.